Hello everyone, my name is Mr. Amoyavi and I am one of your grade 12 advanced maths teachers. In our last lesson, we solved two calculus questions. And calculus being an important subject or content, firstly, we are going to look at multiple choice question. If you look at it, it's an integral symbol and it reads find integral of 1 over 2x dx. And you are required to find an indefinite integral or an antiderivative of this function 1 over 2x. Now, as you can see, the function under the integral symbol is a fractional function or a rational function. And so, according to what you have learned, a standard result that you may have learned is, as you can see, I've got the standard result here. If you are given a fractional function or a rational function, and you are to integrate that rational or fractional function, make sure that the top numerator is the derivative of the bottom denominator function. So if you integrate, then you will end up with natural log of f of x, which is the function at the bottom, which is the denominator, plus the constant of integration. So having this standard result here, we are going to test out the alternative or the choices here by this standard result here. So if I have to look at the first choice here, A, it's if I can look at this one, this function as well as this definition, I have the numerator 1 and 2x. 1 is not the derivative of 2x. Right, so if I look at this, it's not 2x, so A will be cancelled out. And then also, if I have to look at this result here, natural log is involved. So I see that C does not contain the ln or the natural log, so I have to exclude this choice here. Now I've got B and D. So if I have to look at this one, this alternative or this choice here, B, and compare this, I will see that even though this is the function at the bottom, I see this is a problem here, and which does not fit this information or the standard result here. 1 is not the derivative of 2x. So this answer will be off as well. So the most likely answer will be D. Right, so we have to use the standard result again to prove that our answer is the correct answer. So if I have to use this definition, 1 over 2x dx, which is the question itself, and if I have to integrate, now I see that 1 is not the derivative. To use this definition or result, 1 is not the derivative of 2x. So I have to manipulate this expression. And so this can be written as 1 over 2 multiplied by 1 over x dx. Now you see that this expression actually is the same expression or the equivalent of it. So if you want to prove that, it's 1 times 1 is 1, 2 times x is 2. Right, so the constant is normally brought outside, that's half. And then we have the integral of 1 over x. Once we do that, you will see that this expression or the fraction here fits this definition here. So 1 is the derivative of x, right? So using this standard result here, our answer now will be 1 over 2 natural log of the function at the bottom, which is x. All right, and normally the constant of integration is added because we are dealing with an indefinite integral or antiderivative of a function. So in this case here, we don't have a constant of integration for each of the choices here, but if it's a short answer question, you have to add a constant of integration to make your working out complete. All right, so our original guess here is the correct answer. D will be the correct answer for this question here. All right, we are now going to look at a short answer question again on calculus. But before we do that, we have to get rid of what's on the board. Hello and welcome back. Now we are going to look at a short answer question on calculus. And as you can see, we have a question that reads, express the area of the shaded region as definite integral and do not evaluate. Okay, again, this is a typical exam question on calculus. As you look at this diagram, you might get confused with graphs and curves, but actually this graph is connected to the idea of calculus. So you are given a graph of a parabola, and you are asked to find the area between 0 and 2 on the x-axis, and you're asked to calculate the area of this shaded region here. Right, so how do we solve this problem, or how do we find the area of this? It's not a triangle, as you can see. So we have to apply the idea of calculus by integrating this function. So the area of the shaded region is given by, according to the rules that you have learned in calculus, you have to integrate this function. The first thing that you have to do is to integrate this function. So integral of x squared, and write the dx. Your lower limit here is 0 and the upper limit is 2. All right, so how do we integrate this function x squared? Okay, by the rule of integration, we just simply add 1 to the power and divide the old expression by the new power. All right, so what do we do here? We just write x squared and then plus 1, divide by the new power, which is 2 plus 1 again. And don't forget, we can add a constant of integration, but here we are dealing with a definite integral because we have the lower limit and the upper limit. Right, so we can write the expression as in a square bracket, upper limit here and lower limit. Right, so if you simplify what is in this bracket here, it will become x raised to the power of 3 divided by 3, or you can say 1/3 times x cubed. All right, what you have in the bracket is what they call the antiderivative of this function. 2 is the upper limit, lower limit being 0. Now what you need to do is to find f of 2 minus f of this 0 in this function. So what basically you will do is to substitute 2 into this function and then subtract when you substitute 0 into the same function. So you will say 2 cubed divided by 3 minus 0 cubed divided by 3. So if you evaluate, you get 2 raised to the power of 3 is 8. 8 divided by 3. And 0 to the power of 3 is actually 0, and 0 divided by 3 is, again, nothing. So the final answer is going to be 8 over 3. But don't forget, you are asked to find the area of the shaded region here. So area is always expressed in square units. So don't forget to write square unit at the end of the working out. So in order to find the area, you have to integrate this function by the rules of integration that you learned. And then since it's a definite integral, you have to plug in the upper limit, lower limit into the antiderivative that you have calculated to evaluate to get your area. Right, this brings us to the end of our lessons on calculus and also the end of this lesson. What we will now look at in our next lesson will be geometry. And geometry is one of the topics that, again, many students find it difficult according to or as per our survey. Thank you, everyone.